Are you looking for an antenna for your HF station? Let's talk about antenna types and terminology. Welcome to Ask Dave, episode 30. Viewer Ty Williams asked for help sorting through the types of HF antennas on the market and the sometimes obscure terminology used. Most of these antenna types are available from a multitude of manufacturers, and some are easy to make yourself. We'll take a look at some horizontal antenna types, then verticals, and then end with an overview of directional antennas. The dipole is the fundamental antenna, and nearly all antennas in use by amateur radio operators are derivatives of this simple antenna. A simple dipole consists of two elements that are each an electrical quarter wavelength long, for a total length of a half wavelength. Each end is held up by a support of some type, shown here as trees, but it could be between buildings or some sort of mast. The ends are insulated from whatever is holding it up, which could be rope or wire. An insulator at the center separates the two halves and is the point where the feed line is attached to the dipole. Often a balun is used here to convert the unbalanced coax feed to the inherently balanced antenna, although this isn't mandatory. I've made many dipoles over the years without baluns. Single-band dipoles are available commercially, usually for less than $100, or you can easily build one yourself. It's a good idea to get it in the air as much as possible, with a goal of a half wavelength in the air. That's easier on the higher bands where lengths are shorter. Note that a dipole cut for 40 or 80 meters will not cover the entire band with an SWR of less than 2:1, so you will often have to choose which part of the band you use most. Most practical dipole antennas are pretty omnidirectional. They work a bit less well off the ends, but for all practical purposes, you can orient it in a way that fits your situation best. By the way, you can take this same dipole and support it at the center and let the ends droop down. That's called an inverted V and operates very much like a dipole. Note that the anchors can provide a tripping hazard. The next step up is a simple multiband trapped dipole. The traps allow lower frequencies to pass through, but not higher frequencies. For example, if this were a dipole for the 80 and 40 meter bands, the entire antenna radiates on 80 meters, but only the middle portion radiates on 40. Each trap contains some inductance and capacitance, and the combination of the two create a tank circuit which can store energy. The circulating currents can be quite high, and unless the traps are made of very stout wire, can create resistive losses. For this reason, traps are rather unfashionable these days, although they work perfectly well. Here's an antenna that's very popular now. It's called the off-center fed dipole, or OCFD, because it's fed off-center. By playing games with the length and the matching system, the antenna can be resonant on multiple bands. These antennas are available ready-made from several manufacturers, including MFJ. Note that the usual rules apply. The higher the better, and you'll likely need a tuner. Note this is similar in concept to the Wyndham, although the OCFD version is more popular. The end-fed dipole has seen renewed interest because of its convenience. For example, you can attach one end to the house and the other to a tree. The issue with the end-fed dipoles is that the feed point impedance is very high. But the March 2016 QST reviewed an end-fed antenna from My Antennas that seemed to work pretty well. I've spoken on the air with a couple users of this type of antenna, and they're happy with it. The G5RV antenna was developed by a British amateur and is a classic. If all conditions are ideal, it will give a good match on all HF bands, but in practice, you'll likely require a wide-range tuner. The antenna is 102 feet long and has a matching section of 450 ohm window line. MFJ is among the many manufacturers providing these. I've also spoken on the air with several satisfied G5RV users, and shorter versions are available if you don't want 80 meters. Now, for a couple antennas that are not commonly available commercially, but which you can easily build yourself if you have some tall supports. The quad loop is a full wavelength on a single band, and the circumference is a full electrical wavelength. It has the interesting property that where you feed it will determine its polarity, either horizontal or vertical. If you do build this antenna, be sure to keep all parts high enough off the ground so that someone walking about won't run into them. Actually, you can make a loop in about any configuration, even a triangle. This has the advantage of needing only one support, but the disadvantage is that the rope anchoring the lower corners can present a tripping hazard. That was a quick overview of some of the popular horizontal antennas. They all work well and are generally omnidirectional or nearly so. Now we get into verticals. You'll find that various manufacturers have come up with ingenious ways to create compact multi-band antennas that perform about as well as a dipole. The vertical has the advantage of requiring less space and can result in a lower radiation angle, which many hams feel helps them with DX. My antenna is a vertical. Again, this is important. No matter how expensive the vertical, they all perform about the same as a well-mounted, plain old dipole. Here's a simple single-band vertical composed of a metal pole that is a quarter electrical wavelength long. For 40 meters, this would be on the order of 33 feet tall, give or take. But for 20 meters, it's only about 16 or 17 feet tall. This can either be ground-mounted or mounted atop a mast. In either case, you'll need radials. If ground-mounted, you can lay out many random-length radials. The key word here is many. If the antenna is mast-mounted up in the air, then the radials need to be tuned to an electrical quarter wavelength, and you don't need quite so many of them. Note that the pole is fed at the bottom. Given that a vertical is inherently an unbalanced antenna, it can be fed directly with coax. Although note that a ground-mounted vertical has a feed point impedance of around 30 ohms, so you won't get a perfect one-to-one SWR. I note that this is an antenna you can make yourself. If the antenna itself is shorter than an electrical quarter wavelength, the addition of a loading coil at the bottom, perhaps along with a capacitance hat at the top, will allow it to resonate. Such an antenna can even be made to resonate on multiple bands depending on the setting of the loading coil. This type of arrangement is fairly common in mobile antennas, with the car frame and body standing in for the radials. If a small motor is used to change the position of the tap on the loading coil, such an arrangement is often called a screwdriver antenna. An arrangement like this can also be used as a fixed antenna. I would point out that as you add loading, the antenna's Q goes up, meaning its bandwidth goes down, so these antennas often do not cover the entire band without adjusting the loading. A popular arrangement for a multi-band vertical is one with traps. It operates very similarly to the trapped dipole. For example, when operating on 10 meters, the lower section of the antenna is used and the trap cuts off the rest. For 15 meters, we get the next section also. For 20 meters, 3 sections, and for 40 meters, the entire antenna. This is how my very first antenna worked, a high-gain 14 AVQ. One of the issues with the trapped vertical is that only parts of the antenna are used for the higher bands. To counter this, the 43-foot vertical has enjoyed a recent vogue. This is a single 43-foot pole. It works on all bands via an active powered antenna tuner located right at the feed point, which is controlled from your station. The antenna performs well on the lower bands, but as you get into the upper bands, it performs less well. Note that its performance is heavily dependent on an excellent ground radial system. The wire for the 32 or so radials can cost you as much as the antenna itself. Also note that you will almost certainly need to guide this antenna to keep it upright. A variation on the trapped vertical is the multiband vertical with various reactive elements here and there. These allow the entire antenna to be resonant on multiple bands and so avoid the losses associated with traps. Plus, using the entire antenna allows a lower angle of radiation. My butternut HF9V is such an antenna. Note that such an antenna still requires many radials. This is my butternut HF9V, my primary HF antenna. You can see here the various reactive elements such as these coils which provide inductance and these odd-looking horizontal elements which add capacitance. The antenna is ground-mounted over rather poor soil, so I have many radials. I originally installed it with 12 buried bare radials, but while this gives me excellent grounding, these radials don't contribute much to antenna performance. After I refurbished this antenna a couple years ago, I took the opportunity to add many additional radials of varying lengths, all laid on the ground. I chose to use insulated wire. Between being refurbished and the additional radials, I'm quite pleased with its performance. Some years ago, Cushcraft came out with its R5 antenna. What made it unique is that it was an end-fed electrical half-wavelength antenna. Since this is the equivalent of a vertical dipole, no radials are needed. This was a major advance, as anyone who has had to lay out a gazillion radials will tell you. However, all such antennas have a counterpoise. Counterpoises aren't quite radials, but do store energy, so they have reactance. This has an effect on antenna tuning. The antennas are usually multiband, and so often go to great lengths to incorporate various reactive elements so that the antenna will have multiple resonant frequencies, one per band. The R5 was for 20 meters and above. Cushcraft continues to make versions of this antenna that include lower bands as well. I had an R5 for several years and thought it was a fine antenna. Note that you can install the antenna at ground level or, better, put it up higher in the air. By the way, some of the manufacturers say that these antennas have automatic band switching. Well, nothing is actually switched. Rather, the antennas are resonant on multiple bands. So if you switch bands, you don't have to retune anything. Recently, the high-gain AV640 has enjoyed a vogue. Let's talk about all these antennas. Some of these you can easily build yourself. All, from the simplest dipole to the fanciest vertical, have about the same gain. In other words, spending more money on an antenna won't buy you much in terms of performance, although it may buy you quite a bit more flexibility in that you won't need radials and can get the antenna up in the air with a mast and some guys. The various multiband verticals run in the region of several $100s. Some are highly complex and take some time and patience to assemble and get tuned. Once in place, they can be great antennas. I'd like to touch on more complex antennas. In this case, we go from a few $100s to a few tens of thousands of dollars. This is an example of a single-band Yagi atop a tower. Let's look at the parts. The tower has to sit on a base, which is usually a large hole filled with concrete and rebar. The tower itself often comes in sections, which must be assembled as the tower is erected, something that calls for special skill. The tower can be tilt-over, or it can be permanent, or it can be a crank-up tower, which is shortened for storage and for during high winds, and then is cranked up to its full height for operating. Towers are usually guyed with sturdy anchor points, sometimes themselves encased in concrete. The Yagi itself, often called a beam, is composed of several elements, including a boom that runs the length of the antenna, the various elements, such as the reflector and various directors, plus the driven element. All of this is attached to a mast, which goes down into the tower and rests on a thrust bearing, which holds it in position but allows it to rotate. A special rotator is used to twist the mast and hence point the beam. Now, although Yagis can be designed for a single band, most are designed for multiple bands. The classic designs have traps, but the newer designs do without them to avoid the losses inherent in traps. In addition to the popular Yagi, there's also the quad, in which each element is actually a loop. The log periodic is a type of antenna that by its very nature is very wideband or broadband. A recently popular antenna is the hex beam, which instead of a series of linear elements has the various elements bent in such a way as to be hexagonal. I've talked with quite a number of folks who have these and like them. They have the advantage of being lightweight and easy to mount. Some terminology to be aware of is gain, which is a measure of how much the antenna can focus the radiated power. The front-to-back ratio, which is also a measure of how well the beam focuses its power, as often these antennas actually send some energy backward as well as forward. The turning radius describes how much physical space the antenna takes up as it's rotated. The wind loading is the equivalent area that the wind pushes on. The tower must be strong enough to withstand this, and for the larger antennas, the wind loading can be considerable in bad weather. The weight has to do with how much vertical compression the tower needs to withstand, as the larger antennas can be quite heavy. The max torque is the amount of turning power the rotator needs to have to turn the antenna successfully even when the wind is blowing. Overall, antennas like these are for more advanced amateurs who have lots of experience already and the wherewithal to put up a tower. Note that your local planning and building departments will want to have a say in the construction. And if you have a homeowners association, they will likely want to be involved also. These towers and beams are quite an undertaking and are not for those new to the hobby. So, there you have a summary of various HF antenna types and some of the terminology associated with them. I hope this helps you decide what type of antenna you'd like to put up, and helps you understand the various claims the manufacturers make. You can build a simple dipole yourself, or purchase one already made as a first antenna. Then you might decide on one of the store-bought multiband verticals without radials. For several years, I enjoyed taking my Yamaha dirt bike up into the local high country. The road and bridge people try hard to have the roads clear by May 31st every year, but sometimes there's still lots of snow on the ground, even in mid-June, as shown by this picture I took with the camera's built-in timer. Oh, the views! Again, I thank Ty Williams for the suggestion that led to this video. If you liked this video, please share it with your friends. I urge you to subscribe to my channel so that you can get notification of future videos. I have a tip jar on my YouTube channel page and also on my website at ke0og.net, and I gratefully acknowledge those who have supported my channel. The whole purpose of this series is to answer your questions about ham radio, especially those of interest to those new to the hobby. You can ask questions by commenting on any of my videos on YouTube, preferably on the one most directly related to your question, or you can pose a question directly at www.ke0og.net/ask-dave. Until we next meet, 73.